JEE Main 2026, 2nd April Shift 2, Physics Section A, Question 28. Let's visualize the Atwood machine. We have a light frictionless pulley with a string connecting two blocks. On the left, a 2 kg block, and on the right, a 1 kg block. Both start at the same horizontal level and are then released. The heavier block accelerates downward, and the lighter block accelerates upward. The question states, two blocks of masses 2 kg and 1 kg respectively are tied to the ends of a string which passes over a light frictionless pulley. The masses are held at rest at the same horizontal level and then released. The distance traversed by the center of mass into seconds is blank meters. Take G equals 10 meters per second squared. The options are 3.33, 3.12, 2.22, and 1.42. The key concept combines the Atwood machine with center of mass motion. The only external force on the system is gravity. The net external force is m1 minus m2 times g, acting downward. The acceleration of the center of mass equals the net external force divided by the total mass. We can also write it as m1 times a 1 plus m2 times a 2, all divided by m1 plus m2. In an Atwood machine, both blocks have the same magnitude of acceleration but in opposite directions. Block 1 accelerates downward, block 2 accelerates upward. Step 1. Find the acceleration of the blocks. Given m1 equals 2 kg, m2 equals 1 kg, and g equals 10 meters per second squared. For an Atwood machine, the acceleration is m1 minus m2 times g, divided by m1 plus m2. Substituting, we get to minus 1 times 10, divided by 2 plus 1, which equals 10 over 3 meters per second squared. Step 2. Find the acceleration of the center of mass. Taking downward as positive, block 1 has acceleration plus 10 over 3, and block 2 has acceleration minus 10 over 3. The center of mass acceleration equals m1 a 1 plus m2 a 2, divided by m1 plus m2. Substituting, 2 times 10 over 3 plus 1 times minus 10 over 3, all divided by 3. This simplifies to 20 over 3 minus 10 over 3, divided by 3, which gives us 10 over 9 meters per second squared. Step 3. Find the distance traversed by the center of mass. Initial velocity u is 0 since both blocks start from rest. Using s equals ut plus half at squared, we substitute s equals half times 10 over 9 times 2 squared. That gives us half times 10 over 9 times 4, which equals 20 over 9, approximately 2.22 meters. The distance traversed by the center of mass into seconds is 2.22 meters. The correct answer is option 3. Here are some exam tips. Memorize these Atwood machine formulae. The block acceleration is m1 minus m2 times g over m1 plus m2. Here are some exam tips. Memorize these Atwood machine formulae. The block acceleration is m1 minus m2 times g over m1 plus m2. The string tension is 2 meters 1 meter to g over m1 plus m2. And the shortcut for center of mass acceleration is m1 minus m2 quantity squared times g divided by m1 plus m2 quantity squared. This shortcut lets you directly find the cm acceleration without computing individual block accelerations first. Like and subscribe for more JEE Main solutions at MAGPIEHUB.